Hello everyone, welcome to today's session. And for this session, we'll be talking about the quadratic equation. And under quadratic equation, we'll be treating the factorization method. We also have the completing the square. And also the quadratic formula. Quadratic formula method. And under this topic, we'll be solving a lot of examples, So the first we'll be doing, we'll be starting with the factorization method, to solve this question. Now, before then, I want us to treat this like the sum and product of roots. Now, this will help us out in solving this question. Okay. Now, assuming you have alpha and beta to be the root of a quadratic equation. Now, we want to find the product of the root and also want to find the sum of the root. Now, for me, when you have alpha and beta to be this root of a quadratic equation, so we can have s to be equals to alpha and s to be equals to beta. So when we combine the two together, we can have s minus alpha to be equals to 0 and also s minus beta to be equals to 0. So we have this s minus alpha and s minus beta to be equals to 0. Now we can expand this expression. So when we expand this, we have s squared, which is s multiplied by s. We have s squared minus s multiplied by this. So we have beta s. Then this to this, we have minus alpha s minus alpha s. Then minus alpha multiplied by minus beta. So we have plus alpha beta to be equal to 0. Now the coefficient of s in both cases is minus beta and also minus alpha. So we can combine these two together to be s squared minus alpha plus beta s plus alpha beta, which is equal to 0. Now remember, like the normal quadratic equation is always in this format, which is as squared plus bs plus c, which is equal to 0. Now we can compare the two together. If you call this equation 1 and this equation 2, when we compare these two together, our s squared is this, while this is for this, and the constant value is for this. So we can deduce from here that minus alpha plus beta is equals to b plus b. So from here, we can have alpha plus beta to be equals to minus b. Now this is what we call the sum of roots. Then for the product, we have alpha beta to be equal to c. Now which is the product of roots. Now we can use this expression here to solve any factorization. To factorize any expression at all. Now let's try this out. When we have this for the a, you have b squared minus 5b plus c equals 0. Now we need to find the sum of roots. Now we want to factorize this expression, but before we need to find the sum of roots and also the product of roots. Now, if you recall from here that the sum of roots is this, while the product of roots is what we have here. So the sum of roots is alpha plus beta, which is to be equal to this. Now we are going to look for two expressions, the two values. Now in which, when you add the two values together, it will give you minus 5. And when you multiply the two values together, it will give us plus 6. Now this is the sum of the root, and this is the product of the root. Now the two possible values are 2 and 3. When you add the 2 plus 3, it will give you 5. The one you multiply to 2 and 3, it will also give you 6. So from here, we can write this expression to be d squared minus 2d minus 3d plus 6, which is equal to 0. Now this expression and this expression are saying the same thing. Your minus 2d minus 3d will give you minus 5d. Now from there, we can bring the first two and the last two together. So we have this and also have this expression. So from here, we can factorize. So you have d to be d squared to be d minus 2. The one you bring out the common values from here. Now, and also from here, sorry. Now, if you expand this, minus 3d, minus multiplied by 3d. Sorry, let me do something here. So, let's see the same thing. So you have this squared minus 2d minus 3d to be n plus 6 equals to 0. Now we can bring these two expressions together. If you have d squared minus 2d, then minus 3d minus 6 to be equal to 0. Now, when you expand this expression, minus multiplied by 3d is to give you minus 3d. Then minus multiplied by minus 6 to give you plus 6. So you have that. Now, if you bring out the common values, which is d, so you have d to be d minus 2. And the common value here, 3. The 3 can divide both. So you have minus 3 d minus 2 to be equal to 0. Now, when you expand this, you will get this. So you can have d minus 3 and d minus 2 to be 0. So you have d to be equal to 6. So you have d minus 3 to be 0 and d minus 2 to be 0. So from here, d equals to 2, d equals to 3 and d equals to 2. So the values are 3 and 2.